Today, we are going to be exploring Ansible. It's a powerful tool that supercharges system administration. I've been using Ansible for over 5 years now, and I can confidently say it is the gold standard for managing Linux systems. As a disclaimer, this video is a bit technical. I'm going to assume that you have at least a basic understanding of the Linux operating system and server administration. I'll give examples and explanations where I can throughout the video. Before we touch on the AI piece, let's break this down just a bit. What is Ansible? Ansible automates system administration. Now, I'm sure a lot of you know exactly what those words mean, but for those who don't, let me explain. Before Ansible, if you had a job as a Linux administrator, whenever you needed to make a change on a system, let's say delete a file from a server, you would have to log into that server either physically or remotely, run the command to delete that file. In this case, it doesn't sound too bad if there's only one server. But what happens when you have to delete this file from 50 or 100 servers? You'd have to repeat that process at least 50 to 100 times. And as you can see, that's very inefficient. It would take a lot of time and you'd end up probably being really annoyed. Ansible allows us to manage multiple systems simultaneously using repeatable and streamlined scripts called playbooks. The playbooks not only execute our commands, but also act as a source of truth for our environment. So we know exactly what's going on each individual server. We know which packages are installed, which users are created, which groups are installed, and things like that. Now, I'm a big fan of Ansible, but it is important to acknowledge that it does have a pretty steep learning curve. Creating playbooks and roles can take time, especially when you're dealing with complex tasks that need to be executed in a specific order. This usually isn't a problem for seasoned Ansible users. It typically takes me about 15 to 20 minutes to get a playbook up and running. But for users who aren't as experienced in system administration or Ansible itself, it can be challenging to get up and running. And this can take away from some of the usefulness of Ansible. This is where the AI comes into play. Today, I'm going to demonstrate how we can leverage artificial intelligence to enhance our Ansible workflow. Specifically, I'll be using Python, LangChain, and OpenAI's GPT4 model to rapidly create Ansible playbooks and roles. So without wasting any time, let's jump right in. All right, so what I'm gonna do is give you a brief overview of the code that I wrote for our Ansible AI generation tool. After I go over the code, we'll run through some examples, how it works, and why it's useful. So let's get started. This is the whole directory here for Ansible Beam. The llm_model.py file is what we're in now. And this basically does all the work to initialize the LLM model, as well as defines some output templates. Here we have two classes, playbook resource and role resource. What they essentially do is define the JSON output of the GPT-4 model. So when we send a response to GPT-4, we want an output with these keys: resource type, file name, and playbook. They should match these descriptions, and in this case should be playbooks. The name of the Ansible playbook being generated. So in this case, the language model will generate a name for the playbook it creates. In this key, it will output the actual playbook. So we have something similar for roles, but it has role specific keys. And then here we have a class that just combines those two classes, and that way we just call this resource class instead of calling those individually. That gives us kind of like a way to dynamically create resources. So we have a union of the playbook resource and the role resource, and now what happens is we call this resource class based on what we ask the LLM. One of these will get picked. So the rest is just initializing the OpenAI, initializing the chat model, initializing the parser This is also very important because Ansible playbooks need to be in YAML. This is provided by LangChain's library. Like I said earlier, we call this resource class. It just dynamically picks based on what our request is. So then we have some more chat model specific stuff. Here's where we set up our prompt, and I can show you our prompt here. It's a pretty long prompt. We have some variables that get injected to it. So for example, resource type is one, context, and we also inject format instructions. So the prompt goes, you are an assistant for question answering tasks with extensive experience as a software engineer and system administrator. You have deep knowledge of programming languages such as Python, JavaScript, and C#, as well as infrastructure languages like Ansible and Terraform. I'm really proud of this prompt. I wrote it all myself and it works really well. Moving on to the main part of the tool is beam.py. So this is where everything happens. One class that just defines, I think, 8 methods. So it's the Ansible resource generator class. The methods are all pretty self-explanatory. You have our initialization function. This one just defines the name of Pinecone. Pinecone is a vector database, if you don't know what that is. Language models use vector databases. Think of it as a database for a language model. You can put data in the vector database and the language model can then retrieve that data to respond to your queries. Next, we have a get user input function. What this does, it just asks the user what kind of Ansible resource do you want to create, playbook or role, and it just validates your input. So you should say playbook or role. If not, it's invalid. Next, it will ask what should the resource type do. So what should the playbook or role do? You will enter, your request, and that will be saved. Next, we have load documents function. So what this does is it loads all your playbooks into the vector database. So why are we doing that? The cool thing about Beam is that it doesn't just generate random playbooks. What it does is, if you have existing playbooks, it takes your existing playbooks, pushes them into a vector database, and then when you make a request for a new playbook, it uses your existing playbooks as context. If you write a specific module consistently, you like to use it. Maybe you just have some environment specific configurations in your Ansible playbook. What will happen is Beam will be able to use your existing stuff as context, create a resource for you that should be instantly runnable in your environment. Like, you shouldn't have to tweak it. Once you save it, you should be able to run it because it follows the rules of your environment based on the context. Next, split documents. This is more vector database specific stuff. So here, more vector database stuff. So this creates the vector store. So here we have a new resource chain. LangChain, which is the framework I use, it has an object type, I guess you can call it, instantiating a chain. Inside it, I just put the LLM, my prompt, and our output parser is where we invoke the chain. So conversation invoke, and this is where we input our input variables. So the questions we were asked in the beginning of the script. So description, resource type, and then it inputs that. All these variables get inputted into our template or injected into our template. So here I have a little diagram for you, and this is just so we can understand a lot clearer. I think visuals are very helpful. We have two system engineers here, engineer A and engineer B. Engineer A is a new engineer. He just recently got hired, so as you can see, he's very excited. Engineer B, a mature engineer, experienced. He's a baller. He's been doing it for a while, so he knows what he's doing. They are given 3 goals. The goals are to create user accounts, install packages, and create a subdirectory. Engineer A does not use Ansible. He doesn't know about Ansible, so he's gonna do this the manual way. Engineer B does use Ansible, so he's gonna do it with Ansible. And I'm gonna show you really quick what their workflow will look like. Engineer A will have to access each server individually. So he's gonna have to go to the web server, create users Toby and Ray, install packages, Vim, Firefox, and Git, and create a subdirectory named resumes in the temp folder. When he's done there, he'll log out and come here and repeat. When he's done here, he'll log out, he'll come here and repeat. And when he's done here, he'll report back to his boss, and say, hey boss, I'm done, I'm going home for the day. Engineer B, he uses Ansible. He doesn't have this same workflow. He's gonna write an Ansible playbook that creates users, installs packages, and creates that subdirectory. And then from his Ansible controller, he's gonna deploy that playbook to all 3 servers at once. And then he'll report back to boss. You might get the gist just from looking at this diagram, but method B is a lot faster than method A, especially the more servers you add. If the boss increases our server count to, let's say, 20 servers or 40 servers, engineer A will end up spending a lot of time at work that day, while engineer B might be done with that task in 10 minutes, maybe even shorter. I'm gonna show you an example of this being done the manual way, like engineer A, with Ansible, like engineer B, and then I'm gonna show you how fast it'll go if we use Ansible and my tool, Ansible Beam. Before I start, I do want to point out that Red Hat, the owners of Ansible, do have an AI generation tool called Ansible LightSpeed. I haven't gotten a chance to check it out, but from what I've seen, it looks cool. It's very similar to GitHub Copilot, and Ansible says it's trained to specifically make and generate Ansible playbooks. But the problem with LightSpeed is that it's behind a Red Hat subscription. And if you know anything about Red Hat, you know those subscriptions are expensive. So what I've made is essentially a free and open source version of LightSpeed. All right, so what I have here is the 3 servers that our engineers are expected to work on. So this is the game server, file server, and web server. Notice the 1 behind each. So the 1 means this is the yellow. They are yellow servers. 2s will be blue servers. So I'm gonna run through each of these tasks and start the timer, and we're gonna see how long it takes me to finish each task on all 3 servers, the manual way. So first off, let's create users Toby and Ray. The command for creating users is user add Toby. We can ignore that, and user add Ray. Now ID Ray and ID Toby, cool. So that's done. Install packages, Vim, Firefox, and Git. The command for installing those packages is dnf install Vim, Firefox, Git-y. Nice. Now we're gonna create the subdirectory resumes in the temp folder. So let's cd to temp, and the command for that would be mkdir resumes. So there we have our resumes subdirectory, and we can say Vim version. So Vim is installed, Firefox version, Firefox is installed, and Git is installed. So I'm gonna run through those commands on the next 2 servers. We'll fast forward through that. I'll stop the timer when I'm done. I just finished doing 3 servers the manual way, and it took me 6 minutes and 20 seconds. Not bad, to be honest. But like I said, it gets worse the more servers we add. So if this goes up to 10, 20, 30, 40 servers, we can imagine the time only gets, takes longer and longer. So now let's do this with Ansible. I am on my Ansible controller here. What I'm gonna do is, I always like to cheat and get a template. Let's restart that. Start it again. We'll create a new file and we'll name it YouTube work.yaml, and we insert what we just did, change some values, become true. Say finish YouTube task for boss. So the cool thing about Visual Studio and just the world in general right now is that AI is everywhere. You can already use AI to write Ansible playbooks in VS Code. It'll be line by line, right? And that's not bad. It's still pretty useful in this case. And we'll see here, that was quick and nice. So now we wrote the playbook, and let's go over it really quickly. So we have 3 plays The first play creates users Ray and Toby. Second play installs Vim, Git, and Firefox. Third play creates subdirectory in temp. The way I run that in my environment is APB. Okay, so the way we would run this in my environment is we would run APB YouTube work.yaml L game server 1 file server, not 1, 2 actually. 2 is the other set of servers. File server 2 and web server 2. So it created our users, Ray and Toby. It installed Vim, Git, and Firefox. You see it says okay because it sees that they are already installed, so that's good. And then it creates our subdirectories and we are done. So that took us 7 minutes and 17 seconds. I know what you're thinking. That was longer than the manual process. And that's true. And a lot of times that will be true when you're doing something new with Ansible that you've never done before. It might take longer to write the playbook and execute it than it would to just manually make the changes on the system. But the advantage is if you have to do it again, it will take virtually no time because now all you have to do is run the script. You have a repeatable script that you can use to make those changes now. 6 minutes manually, 7 minutes with Ansible. So now we're gonna do this with my Ansible AI tool, Beam. Let's see how long it takes. I've restarted the clock and we're gonna start. Now, to run Beam, you have to run Python 3 and then the path of the Beam package or the Beam script. So that is home, Beam, source, beam.py. So as you can see, it asks what kind of Ansible resource do you want to create? I would say a playbook. What should the playbook do? It should create users Ray and Toby, install packages, Vim, Git, and Firefox, and finally create subdirectory named resumes in temp. Will give us our playbook. It creates user Ray, creates user Toby, installs Vim, installs Git, installs Firefox, and creates it subdirectory in resumes. It does it in a, I would say, not so efficient way, but it works. Make changes? No, I do not. Do you want to save the generated Ansible resource? Yes, I do. It tells me the playbook generated and saved, and it's called create users and install packages.yaml. So now if I want to run that, I can run that same format of command that we ran earlier, but we will use the create users and install packages. So now you'll see we're running APB, create users and install packages.yaml, and the 3 servers that we're working on. And let's just go ahead and run this command. And now you'll see it create users. They're already there, so it'll be green. It installs Vim, installs Firefox, and it creates subdirectories, and it's done. That took us 3 minutes, and it could have took us even less time if I wasn't talking so much. Now, as you can see, we cut down the time it took to create this playbook significantly. We didn't have to do as much debugging. When you write your own playbook, sometimes you'll have syntax errors and you'll have to sit there and debug your code for a while. In this case, we didn't have to do that. It was formatted correctly and we were able to run it in 3 minutes. And that is the power of Ansible and AI. So I hope you guys see the value of this, and I hope you think it's as cool as I do. Okay, so now you know how to make an Ansible playbook or role the fastest way possible with AI. Awesome. I'm happy for you. So you might have noticed that I didn't show you how to use Ansible Beam to create roles. And that's just because I didn't want this video to be too technical. Roles can be kind of hard for people to understand, I've noticed. So maybe if you guys want me to do that in the future, I can, but I just left that out for now. Also, I will be putting this project on GitHub, And if any of you guys want to make contributions and help out with new features, you know, you're more than welcome to. I'll review any PRs and merge them. Also, I just want you to keep in mind that this project isn't just for a work context. This doesn't just apply to a work context, right? Like, I use Ansible Beam at home to write playbooks for my home services, and it works pretty well. I've written patching playbooks, general system administration playbooks for some of my services, so to change things like sudoers and ZSH environment, things like that. Yeah. If you like the video, appreciate you for staying this long. I'll be back soon with more. Peace.